Yes. And then like the group of people were just like chill, like doing things, like in their own. They're like automatic, like this is the wrong thing. This is the wrong thing. What's up, guys?
Hey,
How you doing? You guys here for Algorand? Or are you just looking for a room? Algorand? Okay, so my name is Paul. I am here from Algorand to talk to you guys about a little bit about our project, some momentum we've been having, and ways to develop and kind of get involved. Sound good? Yeah? All right. So I'm Paul, like I said. I probably don't need the microphone unless it's connected to something else, in which case I'll stand okay, so I'm Paul. I'm head of product at Algorand. That means I run product management, product strategy, and development relations. My experience is really around both high-growth startups. So I came from a company called Carbon Black, which is an endpoint cybersecurity company in Waltham. I started when we were about 60 people. I was the only product manager. By the time I left, we had scaled all the way to 1,300, gone through an IPO. And if you saw in the news maybe 2 weeks ago, they were acquired for $2.1 billion in an all-cash deal with VMware, which doesn't suck. I also have experience at large enterprises, at IBM, which is one of the largest ones you can get out there, 350,000 employees, which I think gives me a really unique kind of perspective on building products, having seen both a place with very little process, and then having to kind of change how you do things along the way up to scale up, and then getting to the very largest and seeing all of the process all of the time. Just real briefly, if you're wondering, hey, what is Algorand? So we're a foundational public and permissionless proof-of-stake protocol. We're super technologically focused and innovation focused, which I think is a little bit different than some of the project space, where you see projects released, they don't see a lot of innovation happening. My personal belief is that what blockchain technology looks like in 3 years would be mostly unrecognizable from what the underlying blockchain technology looks like now. And we want to be at the forefront of that and stay on the forefront of that. And one of the ways we do that is through our research team. Our founder, for example, Silvio Macaulay, he's a cryptography pioneer, he's a Turing Award winner, he's an MIT professor, and he kind of underpins he underpins our research team and pushes on that technical innovation. A lot of names, I'm not going to go through them, but just to kind of give you an idea of what our project is like, we're one of the more substantial projects in terms of the folks that we have behind it that you'll see out there. So we talked about Silvio. Our CEO, Steve Kokinos, he's also the CEO and founder of a company called Fuse here in Boston, if you're familiar with them, and also a founder at a company called Blade Logic. If you've read the book, The Hard Thing About Hard Things, Blade Logic is a company that's often mentioned as the sort of nemesis of the main characters. Sean Ford on the business side as well. He was a CMO at LogMeIn for the last 4 years, a founder at Promise and an early employee at Monitor Group. The research team, this is only some of our research team. You can see a lot of MIT stuff on there. We've got a team of 14 researchers who are focused entirely on innovation around economics, cryptography, game theory, distributed systems, and that's what their focus is full time. We also have a corresponding engineering team of about 14 folks that are really focused on A, translating that research into something we can implement, and then B, really executing around what we can build on top of those innovations. We want to make sure that we don't get too academic focused. We want to make sure that not only do we have that academic sort of breakthroughs, but then also build value. That's the job here. So I'll go like a couple inches deep here on our technology, and then kind of come back up and talk about the things that developers are looking at and the traction that we're seeing there. So as far as our core technology, there's a couple different approaches to consensus or agreement code that are out there right now. If you're familiar with Ethereum, which I guess everyone is, if you're familiar with proof of work, you're probably also familiar with delegated proof of stake, where it's stake-based, but I actually give it to someone else to vote for me, or bonded proof of stake, where I take some amount of my stake, I put that up in bond, and that can get slashed, etc. There's definitely pros and cons to each one of these. I'm not here to tell you they're all terrible, but definitely pros and cons. You see with a lot of proof of work protocols, you have a lower transaction speed, lower finality. Delegated proof of stake, bonded proof of stake, you tend to have a very small group who's in charge of a very large group. We have what we call a pure proof of stake. There's no penalties, there's no slashing. You're not delegating money to someone else or you vote to someone else. And we do that in a couple of different ways. So first of all, to take a step back, we have, when we agree on blocks, we have an ever-changing sequence of committees. So what does that mean? There's effectively 3 steps in our block confirmation process: a block proposal, a soft vote, and then a cert vote. Each one of those is a separate committee, and it changes for every block, and it changes for every round within every block. Each committee is roughly 1,000 users that are randomly, independently selected, and they only have to send a very short, single, easy message in terms of their vote. So what does that allow us to do? Or I guess we can go a little bit deeper on the committee itself. So who selects that committee, right? That's a common question for our consensus. Each committee member actually selects themselves, so they run a private lottery. If you're familiar with verifiable random functions, that's the cryptographic primitive that we use, which Silvio Macaulay was actually a co-founder of a number of years ago. VRFs have 2 really interesting capabilities or properties, one of which is you can't cheat a VRF, like you can't fake that you have won it, and 2, you can always actually prove that you have won it. And if you combine those 2 things, it's a really good way to be able to select committee members in this kind of situation. If you win that lottery, so the VRF says, yes, I have won, then you participate in that committee and continue on. The probability of you winning that lottery or being selected by that VRF is proportional to your total amount of money in the system, so proof of stake. So what does that provide? Well, first of all, it provides really good decentralization around the agreement itself, because literally everybody in the system is eligible to participate. Everybody in the system can be a block proposer. Everybody in the system can be a block confirmer or a verifier, which is very different than a lot of other systems where you end up with a couple of classes of users. Hey, these guys are the proposers, these guys are the verifiers, these guys are the users. That is not the case in Algorand. It's super decentralized from that standpoint. Secondly, it's super scalable. So the size of the committee, we have the mathematical proofs on the back end. The size of the committee does not need the size or the scale of your user base. So even though you can go up to millions, hundreds of millions, billions of users, the committee sizes don't have to change. And that means that we can still reach consensus at the same speeds, even with a lot of users, that you could with very few users. And then finally, on the secure side. So what's interesting about this, the selection process in the VRF, is that you don't know who the voters are. So as an attacker, I could say, oh, well, this is easy. If I know who the committee member is, I'll go corrupt that committee member, and then I can break your consensus effort. The thing with the VRF is, when you are selected or when you have won the lottery, you have to send one message. That message essentially says 2 things. 1, I guess 3 things. 1, I have won that lottery. 2, here's the proof that proves it. And 3, here's my vote. So that's one message, which means you don't know who the committee member is until after they have voted. Oh, and by the way, if they've already voted, they're no longer part of the committee, because now there's a whole new committee. So you can't get to the individual voters because you don't know who they are, and they're constantly changing. By the time you know who they are, they've already voted and are no longer a committee member. And so if you're familiar with the blockchain trilemma, pick 2, decentralization, scalable, secure, we feel like our consensus algorithm is a great start for being able to solve that trilemma and actually achieve all 3 of those properties. But we're not done. We talked about being innovation focused. This is just the start. We've got a lot of innovation coming. I can take you through a little bit of that. So from a high level, there's not just the consensus algorithm, there's a bunch of other properties too that are super interesting. Core technical benefits of our blockchain, minimal computation required. We talked about anyone can participate. Also, it's energy super efficient. Our founder wrote this slide. He's Italian. He put super after energy instead of before energy. Always trips me up. It's very energy efficient because you're not solving any hash puzzles, you're not trying to do anything special, you're literally sending one vote with a message. Secondly, we protect both against protocol attacks and network attacks. So what do I mean by that? When you think about a partition, if your network is partitioned, you usually have to make a trade-off. And that trade-off is, am I going to choose liveness, continue to create blocks on the chain, or am I going to choose safety, which is to say there won't be a fork in my network. Most chains choose liveness. So for instance, I'm going to use Bitcoin as an example. When there's a partition, each side of that partition will continue to create blocks. When that partition comes back together, one of those chains has got to decide, yep, I'm actually the real chain, and you drop all the transactions. That is not the case in Algorand. We've chosen safety, which means when the network is partitioned, we don't create a block until we have enough votes to bring that together and actually reach consensus. What's interesting about that is we've got a lot of really good feedback from our financial customers and our financial developers who are really want to know if there is a transaction that I have created, is it real, is it final, do I have to wait around and might it get dropped later? That is never a worry with Algorand, and it's been getting a really good reaction. The third thing is that we operate at enterprise speed. What does that mean? 1,000 transactions per second. Will you see 1,000 transactions per second on our mainnet? No, because we don't have that kind of traction yet. However, we run a long-running test, 10,000 nodes globally distributed across 8 countries with evenly distributed stake, which for proof-of-stake algorithms is the hardest sort of configuration. And we can consistently run at 1,000 transactions per second with no degradation in our performance. That's only one half of the equation, though. Block latency also very important. We create blocks in under 5 seconds. Since launch, we launched about 2.5 months ago. We've created about 1.8 million blocks. All of those blocks have been under 5 seconds, and in fact, our average time is about 4.3 seconds. So not only can we process a very high number of transactions, but when you send a transaction, it is final, complete, and done within 5 seconds. And then the final one is this immediate transaction finality. Because we've chosen safety, there's no forks. When a block appears in the blockchain, it is final. We often get the question, okay, great, 5-second blocks. How many confirmations do I have to wait for? You don't have to wait for any confirmations. If the block is there, it's final, the transaction's done. So to flip that into why developers are choosing Algorand right now, the first one, we've talked about this, it lets your application run as fast as it needs to run. It takes the scalability question just completely off the table. The second one, which was kind of interesting, was actually brought to us by companies that have been building apps. It increases the user's confidence in your application. Why is that, or why did we get that feedback? If you have any experience sending crypto to friends or to an application, and you send it, and then you wait 15 minutes to see if it's real or not, and then you use a system where you send the crypto and algo on our network, it's there, it's done, 5 seconds later. It's a fiat-like experience. It's like using PayPal, it's like using Venmo. And it takes your users from a mind space where it's like, oh, I'm using this cool, new, not quite there technology to, oh yeah, that works. Like it fits into their traditional mindset. Third, reducing cost structures. This is, it depends on the type of business, but our transaction fees are very low. They're 1,000th of an algo, which is our native currency. And it won't increase until those blocks get over 1,000 transactions per second. So the cost structure is going to be significantly improved depending on your business model. And then I'm going to combine the last two. So we really strive to make the development process smooth and easy. We've got SDKs across 4 languages, Go, Java, JavaScript, and Python. We've got a provider, PureStake, which is a partner of ours who has put out an API service if you don't want to run a node. It's very Infura-like, if you're familiar with, I expect you are with Infura. And we also want to be a technology partner, which I think is very different for the blockchain world. I'll go back to the traditional world again. In the traditional world, the way you choose a technology provider, like, hey, I'm going to build something on top of the platform. Okay, let me go do my research online, let me call each one of them, let me talk to them, let me set up a meeting, let me see the roadmap, hey, what does your support process look like? All of these things that businesses need, not just large traditional businesses, but new businesses as well to make your experience better, aren't available on other public and permissionless chains. And Algorand has the ability, we are public and permissionless, so you get all of those benefits, but you also get the benefit of a company who is driving the innovation and can meet you and talk to you and help you when you need help. And we found a really good reaction to that capability as well. Which results in a traditional logo slide. It's a lot of stuff, I'm not going to go through it. But I guess the one interesting thing here is that we've been launched for 2.5 months, and every one of these logos up here is either building on Algorand, has built a tool that supports Algorand, accepts Algos, which is our native currency, or is supporting the project in some way, like providing node hosting services. And this kind of traction this early, we feel pretty good about. To get one level down on some of the use cases that are buried in that slide that Mark gave me, we have companies that are building telecommunications and e-payments applications. This is a particularly good application on Algorand because of that transaction speed and because of that finality. Building insurance, decentralized insurance models. Asset tokenization, so there's a company called Asset Block, which is launching basically tokenization of real estate and allowing it to get into markets and users that haven't traditionally had access to that market. Media and entertainment, a company called Otoy, who does digital rendering, GPU rendering, is building a decentralized rendering service on top of Algorand. Enterprise solutions, DApp analytics. This is an interesting one. So a company called Flipside Crypto, which is also based here in Boston, has built a DApp analytics suite where any application who is building on top of Algorand gets a free service from them, which gives insight into your users, where they're going, how much they're spending, what their activities are, by public key, not actually user information. But super useful and something that's not necessarily available for folks this early in their life cycles of product. But we are just getting started. We're super innovation focused. There's a bunch of things coming down the pipe, which I'll just build out here. Some of this stuff is, I'm going to go into a little bit more detail in the yellow. So one of the things that we're really focused on when we think about what we are and think about ourselves as a platform for economic exchange. So if you're going to be a great platform for economic exchange, what do you have to be able to do? Well, first of all, you got to be able to represent all of the assets, right? So we can represent our own native currency, the algo, but what if you want to put boats online, or you want to build your own currency, or you want to build a loyalty point system? How do I build those assets? We're super focused on that. That is coming in the short term. I'll tell you a little bit more about it. Pixel is a technical optimization for aggregating signatures or using the BLS standard. We're helping to formalize, in fact, we're driving that formalization. A number of other chains, including Ethereum, is planning on switching over to BLS and using the standard that we've been driving. Self-validating transactions are super interesting. It allows nodes to not have to keep the state for accounts. We have archival nodes, non-archival nodes. And if you don't have to keep state for the account, you can do a lot of very interesting things in terms of like nodes, like clients, and more. Intra-chain atomic swaps. So when I generally think of atomic swaps, I think cross-chain. I want to give you Ether, you give me Bitcoin. We're focused on intra-chain because of these assets that are coming. And the proliferation of assets on Algorand means we want to be able to do something that's a little bit more interesting than the traditional hash time lock contract. It doesn't have some of the downsides that you see there. And then post-sale trades and full-fledged smart contracts. Frankly, full-fledged smart contracts is something absolutely in our roadmap and we will have. But we think we can solve a lot of those use cases without full-fledged smart contracts, which can increase the security profile or decrease the attack surface of your applications and make it a little bit more easy to get off the ground and get going than creating your own smart contracts. So I just want to, there's a lot of text. If you can't read it, don't worry about it. I want to talk about creating your own assets in layer 1. So this is super flexible in terms of the assets you can create. It covers the full spectrum. That's fungible assets like cryptocurrencies, stablecoins, system credits. And in fact, on the stablecoins front, Tether, I don't know if you saw this announcement about a month and a half ago, Tether has announced that they are going to launch on Algorand. They're going to be using this functionality. Non-fungible tokens like real estate, tickets, collectibles, etc. An example of this would be the asset block where we're tokenizing real estate. And then restricted assets, things like securities, some types of real estate certifications. I keep saying layer 1, or we're creating them in layer 1, and I'm saying like I'm focusing on that for a reason. Layer 1 assets enjoy a security profile that layer 2 don't, or smart contract assets do not enjoy the security profile. So they get to take advantage of all the inherent protections that we put in for our native currency. And I'm sure you've had the experience where either you've made a typo in your smart contract, or you're copying and pasting from somewhere else, and then there's a vulnerability and it sweeps through a whole bunch of ERC20 contracts. or you're just like, why do I have to continue to copy and paste the same thing that everyone else is using? And all of those sort of go away with a layer 1 implementation. It also provides some interesting inherent compatibility. And what I mean by that is any application that's built for any asset on Algorand will automatically support all of the assets on Algorand. And so from a community building and a network effect perspective, you get a really interesting flywheel where there isn't, hey, I built my app and I support these 4, but I want to support those other 7, but it's a lot of work, and they've made some tweaks, and I just don't have time. So if someone can convince me that it makes financial sense, I'll also support them. In the layer 1 model, you already support them. You don't have to do anything more, which is, I think, a really interesting thing for communities. And then the last one, it's like super easy. You send one transaction to the network with like 5 parameters, and your asset is created in 5 seconds. Right? So there's a lot of benefits to that layer 1 capability. And then once you have this ability with this proliferation of assets, you want to be able to exchange them. I want to give you algos, I want to take your vote. I want to give you a ticket and take your algos, or whatever it may be. And so we're introducing this capability of intra-chain atomic swaps. You can exchange any Algorand asset or any other Algorand asset with guaranteed simultaneous execution of the exchange without any locks or time without hash time lock contracts. So there's no multiple steps, there's no waiting. This is some inherent technical innovation that we're bringing to market where it's, we really think it's an improvement on atomic swaps that are out there now. There's a bunch of use cases here. There's the obvious of a bilateral exchange. You have something that I want, I have something that you want. There's also, it supports multilateral exchanges, so I want to give you 10 algos, you want to give him a boat, but only if he gives him a car. We can put that into one transaction and make sure that either all of those happen at the same time or they don't, with the same structure that you would for just a simple bilateral exchange. And there's cool use cases around that. There's all enough funding, right? I'm gonna match your donation to whomever, and it will only occur if the other donation occurs as well. Also for decentralized exchanges. A couple days ago, IDEX, which is one of the largest decentralized exchanges, announced that they're going to build on Algorand. They're going to be taking advantage of intra-chain atomic swaps as well as some other functionality we have to do what we think really takes a leap forward in decentralized exchanges in terms of the user experience and the speed with which you can trade. Our goal is to allow the decentralization that people want, but still give them the traditional fiat world feel in terms of the user experience. And that's really what we're trying to mix together. From a developer resources perspective, if you guys are interested in checking it out, developer.algorand.org is our sort of jumping off spot. It's got all the documentation, it's got our tutorials, we've got sample applications, we've got SDKs that I mentioned earlier. There is also that Infura style API gateway that PureStake offers. We have online forums, developer meetups, hackathons. There's just a lot of ways to get involved here. I definitely recommend that you reach out either through Twitter at Algorand, through our community forums, community.algorand.org, or through that developer site to get any more information that you might need. And other than that, I'm happy to answer any questions you guys might have. That was right on time. 15 seconds. Thank you. Thank you guys. Thank you guys. Anybody? Yeah.
So I may have missed this, but so when I'm creating my own layer 1 assets, are those like ERC20 tokens, solidity contracts, or those?
No, it's so it is not. We don't have smart contracts.
Okay.
This is I would consider a solidity contract layer 2. You're writing it off chain, even though it's getting executed on chain. The actual creation of it is off. So the way that you create it is you literally send a transaction that has like 5 parameters in the transaction to make it a valid transaction, and it just gets created on the back end by the protocol itself.
Oh, cool.
Yeah. And then when you're sending a transaction, instead of sending a standard transaction as you would for an algo, which would just be, to simplify it, from to amount, it's from to amount asset name, right? And that's all it is. So you're using all the same infrastructure. It's going through all the same consensus code. It's as if it was created by the protocol itself at the beginning.
Okay. So I guess a follow-up question is maybe something I missed So it's a separate chain than the EVM, right? It's its own
There is
thing.
no EVM, there is no Ethereum.
Gotcha.
There isn't Ethereum,
Right.
we are not Ethereum. We are Algorand, we are a wholly separate blockchain protocol.
Gotcha.
All right, well thanks everybody, appreciate that.